Hello, everyone, and welcome to another edition of Encora Talks. Our topic for today is blockchain fundamentals and applications. We have such a great speaker. His name is Aditya Chauhan. Aditya has over 12 years of experience designing and developing cloud-based web applications in domains such as digital commerce, health tech, insurance, and energy services. As an engineering manager at Encora, he must understand his customers' needs, analyze their requirements, and design the optimal solution for them. Aditya manages multiple projects and provides technical assistance to all his teams. Hello, Aditya, and thank you so much for being with us today.
Thanks, Sunny. Hey, everyone. Welcome to October edition of Encora Talks. Topic for today's webinar is blockchain fundamentals, and we're also going to see some of its use cases and applications. So this is what I have planned to discuss in next 35-40 minutes. We will see what blockchain is, few technical jargons used in this trending technology, brief history of blockchain, then we'll also see what consensus algorithms are, proof of work. This is one of the most popular consensus algorithm we have in industry right now. Then we'll talk about few of the use cases, industries where blockchain is already used, and there is a potential of potential applications. Followed by a case study, a very popular case study. So let's jump into the topic. Okay, so what is blockchain? The blockchain is chain of blocks. In simple words, it's a new way of storing and transferring data over the internet. So it is simple, like chain of blocks, and these blocks contain some sort of data. Now, what type of data you can store? So you can store any type of data. But you might ask, one might ask that there are already so many existing technologies which are used for data storage and information exchange. Then why is blockchain trending? What is so special about it? So so you can see on my screen, these are the main characteristics which differentiates blockchain from existing database technologies. Number one, data security. So all these blocks which we see in blockchain, these blocks are interconnected, and these are linked together using cryptography. Second, we have data integrity. So blockchain ensures data integrity. All the blocks which we have in blockchain, those are immutable. Means that once you enter any data in any of these blocks, you cannot change that data, you cannot delete that data. And how is blockchain ensuring data security and data integrity? Because it uses two very powerful cryptography mechanism, encryption, asymmetric encryption, and hashing, which we will see in upcoming slides. Next is decentralized. So blockchain is a decentralized and a distributed database. It means there is no central authority here. Data is distributed across multiple nodes. So that there is no central authority here. Next, there is it ensures transparency. Means anybody like you and me, we can access and view all the blocks of a public blockchain. Again, the two bullets here, decentralized and transparency. This might not be true for certain blockchains like private blockchains, because in those blockchains we have a central authority who takes care of this, like who authorizes who can view data, what type of data is authorized to view to a certain audience. But yes, data security and data integrity, these are the two underlying things which is applicable for all types of blockchain. Next, I wanted to show you a sample blockchain. So as I said, this is more of a blockchain is nothing but chain of blocks. So you can see on my screen, we have 4 blocks here. And again, I wanted to show you what exactly goes in a block. So first we have a block number, a sequence number, followed by data, the actual data which you want to keep in this block. Next, we have nonce and hash value. Now, for now, just digest. I will come to nonce and what nonce and hash value are. But for now, just you can think of these as something which we have to store in every block. Next, very important, that it also contains a previous block hash value. So you remember on the first slide, I mentioned that blockchain is in blockchain, all the blocks are interconnected using cryptography. So this is how these are interconnected and linked, because the subsequent block, block number 1, n+1, is having a hash value of block number n. So that way, if I try to change anything in any block, I cannot do that. The moment I try to do it, it will invalidate the whole chain. So this is how using cryptography hashing, we are ensuring data integrity and data security. Next question is like what type of data you can store in blockchain. So you can store, as I said, you can store any type of data. You can store person's identity, SSN. You can store products inventory. You can store purchase records, transaction. Not even data. You can also you can embed certain code in blockchain. I mean, I just talked about smart contracts, but more on that in the upcoming slides. Again, to summarize, you can store any type of data in this blockchain. But main point is that just because you can do it doesn't mean you should do it. And I have a dedicated slide for this, which talks about that what type of data you should actually store in a blockchain. Next, I mentioned that blockchain is a distributed and decentralized system. What does that mean? You can see on my screen, I have 3 nodes here. So just for illustration purposes, I mean, I have simplified this. Of course, there are more nodes, like there are multiple nodes. But here on my screen, you can see that I have 3 nodes, and each node has same block. So that means like the entire copy of that blockchain is available on all the nodes. So that way, we are ensuring that there is no central authority. In fact, that power is distributed across all the nodes. That whatever nodes we have in that blockchain network, the entire copy of data is available on all the nodes. So you can see there is no central authority here. There is no single point of failure. So this is what makes blockchain distributed and decentralized. Okay, let's take a look into a quick demo. So you can see on my screen, we have this. We have a block. We have around 5 blocks here, and each block has a block number, is the sequence number of that block. Then there is something called nonce. Now, what is this nonce? Nonce is an abbreviation. It stands for number used only once. So this nonce thing is basically core of the blockchain technology. And again, when we will talk about proof of work consensus algorithm, at that time we will revisit this concept. But for now, just think of it in this way, that each block will have a nonce value, and nonce stands for a unique number. Then of course, the actual data which you want to keep in that block, we have that, and then we have a previous hash value. So since this is the first block in this chain, which is also called Genesis block, that's the reason the previous hash block here is 0. But if you see the second block, the hash value of this block, like 000157, I can see that same hash value being repeated here. So similarly, if I see the third block, the previous hash value 0012, that is same as the hash value of the second block. So you see all these blocks are interconnected. And I mean, in addition to previous hash block, of course, we have something called hash value also. So in each of these blocks, you basically you take an input data, you apply some hashing function on top of it, and then it will give you a fixed length of output. That is called hash value. More about hashing. So you can see on my screen, this is another demo. So hashing, what is hashing? Hashing is basically a cryptographic mechanism which is very helpful when it comes to exchange of information. And how is it ensuring data integrity and data security? Because here I can provide any length of input. Regardless of my length of input, I'm always getting a fixed length of output. So you can see, and again, another important thing here is that this hashing is irreversible. Means if I have the hash value, I cannot go back and determine what was the original text, what was the original value. So this is what hashing is. It's a cryptographic mechanism which takes a plain text, applies a mathematical operation on that plain text, and gives you a fixed length of output or a hash value. And what is that fixed length? That depends on what type of algorithm you are using. For instance, if you are using SHA-256, then it is always going to give you 256 bits of output value. If you are using MD5, then it is always going to give you 4-character output value. So there are multiple hashing functions in industry. Most popular one, of course, is SHA-256, which you can see on your screen. Going back to our demo, so you can see that here, all these blocks are interconnected. Now, now how are we ensuring data security here? By XYZ means, a bad actor gets hold of this block, and if they try to change data here, you can see the whole chain gets invalidated. Why? Because moment I edited the data, I changed the hash value here, and all the subsequent blocks were notified about it, and that's how I ended up invalidating this whole chain. So if I have to rectify it, I have to take it back to the original state. That means that the blockchain technology is immutable. I mean, these blocks are immutable. I cannot change the data. And if I try to change anything, it will invalidate that whole chain. And the other nodes of that particular network, they will be notified about it, and they can simply discard that bad actor node from that chain. That is how we are ensuring that data security and data integrity. Going back to our presentation. Okay, let's discuss a few common terminologies which are used in blockchain. So number one is public key cryptography. It is also called as asymmetric encryption. So what is asymmetric encryption? Asymmetric encryption or public key cryptography is a way in cryptography, is a mechanism in cryptography which is used for exchange of information between two parties in a secure manner. So each party here has a pair of key, like a public key and a private key. So for instance, if party A needs to send some data to party B, this party A will have a public key and a private key. Party A can use their private key, which is a secret and confidential thing. They can use that private key to encrypt the data and then send it over the network. When party B receives that data, they will have access to the public key of this party A, because public key is something which is publicly available. So they can party B can use party A's public key, and they can decrypt the data. That way, you are ensuring the secure exchange of information here. Party A was able to exchange the information securely with party B. You can think of public key and private key as in your email address. Like public key is similar to your email address. You are comfortable sharing that with everyone. So public key is like your email address, and the password to your email account is something similar to your private key, which is something secret and confidential, which you will not share with anyone. So yeah, this is what public key cryptography is. Next, we have hashing. We already saw it in the demo, but I'm just a quick recap that hashing is a cryptographic mechanism, another cryptographic mechanism which is used heavily in blockchain. And how is it used? Because you take a plain input, you take a plain data, you apply some mathematical operations on it, those are called hash function, and then you get a fixed length of output. Unlike encryption, hashing is irreversible. You cannot change the data back. In encryption, you are able to do it, but with hashing, you cannot do that. Now, both this public key cryptography and hashing are heavily used in blockchain network, because these are the two main pillars of cryptography which ensures data security and data integrity, two major characteristics of blockchain. Next, we have consensus algorithm. So there are different consensus algorithm, proof of work, proof of stake, proof of capacity, and so on. But I have a dedicated slide for this, so I'm skipping it for now. Next, let's talk about fungible and non-fungible. Now, fungible and non-fungible, these are economic terms. Fungible assets are those assets or those goods where they have a fixed value, or whose value could be traded or they could be exchanged. For example, a dollar bill. You can exchange a dollar bill with another dollar bill because they both have a same value. Though a serial number might be different, but the value is same. So fungible assets are those assets whose value is same, who could be exchanged. On the other hand, non-fungible assets are those assets or those goods whose value is unique, and you cannot exchange them with any other asset. So going back to the dollar example, so if you take a dollar bill and your famous artist or a celebrity does an autograph on it, then it becomes a non-fungible asset. Why? Because it is not, now that dollar bill is no more a normal dollar bill. You have a celebrity signing on it. That now you have changed. It is unique in its way. It has become a non-fungible economic asset. More on fungible and non-fungible when we talk about NFT in our upcoming slides. Okay, let's talk about brief history of blockchain. Now, people have this misconception that blockchain blockchain came into existence with Bitcoin back in 2008 and 9, but that is not true. Blockchain goes beyond that. Back in 1991, Stuart Haber and Scott, these two researchers, they came up with this idea, same idea of having a chain of blocks, and these blocks would be immutable. Again, this was just a concept. Nothing was materialized. There was no practical implementation. It was just a theoretical concept. A year later, in 1992, they strengthened this idea by adding a concept of Merkle trees to their project. But again, this was just on paper, and there was no practical implementation. Fast forward, down the line, 6 years, 1998, there was an attempt to create a decentralized digital currency on similar lines like what we have with Bitcoin. That Bitcoin is a decentralized digital currency where you can do peer-to-peer transaction. So a computer scientist by name Nick, he came up with this concept of Bitcoin. It's another decentralized digital currency. Same thing, it was just a theoretical concept and it was not that popular. Fast forward 10 years down the line, Satoshi Nakamoto, again, nobody knows if this was a person or a group of person. It's an anonymous group or a person. Satoshi Nakamoto published a white paper. This white paper was all about possibility of doing peer-to-peer transaction without a central authority. So idea was to have a decentralized digital currency. That is when Bitcoin was invented. Now, again, this 2008, this was just a white paper, and January 3rd, 2009, this group actually mined the first block of blockchain. It was practically implemented. That concept of having a decentralized digital currency for doing peer-to-peer transaction, that came into existence with commencement of Bitcoin. It took 4 years for Bitcoin market to cross total $1 billion USD valuation, and that is when it grabbed the attention. People started thinking blockchain, they realized how powerful this technology could be. And 2014, we call it as a blockchain 2.0 era, when industry started thinking blockchain beyond cryptocurrencies. And then that is when Ethereum, there was a new toolkit in the market. And fast forward 2018 plus, now we have smart contracts, Ripple, NFTs, Internet of Things, and so many things. So yeah, this is how blockchain has evolved over a period of time. Let's a quick recap of what blockchain is and what blockchain. I mean, before we talk about what blockchain is, it is very important to know what blockchain is not. So it's not a product. Again, Bitcoin, Ethereum, smart contracts, you can label them as a product of blockchain, but blockchain in itself is not a product. It's a technology behind these products. So it's an underlying technology beyond all these popular products. Blockchain is not replacement of traditional database. That's a problem with industry. Like when something comes, some new technology comes, people started thinking of it as a replacement of existing thing. That is not entirely true. Like we had NoSQL traditional RDBMS, and then we had NoSQL databases like Elasticsearch, MongoDB, and all. That doesn't mean people have stopped using RDBMS. Every type of database have their own value and have their own characteristics. The same goes with blockchain. Traditional databases have their own place, and blockchain has its own use cases. More we will see in the coming slides where exactly you should use blockchain. It's not better than existing databases because, as I said, each database has their own characteristics. Now, blockchain is not Bitcoin. Very common misconception. People often think Bitcoin is blockchain and vice versa. Bitcoin is just one of the very popular use case of or application of blockchain. The underlying technology behind Bitcoin is blockchain, but blockchain is beyond that. I mean, it is so much powerful that you can build many applications using that. It is not completely anonymous. Now, and it is not used only in dark web or illegal activities. So people have this I mean, we often read articles in blogs here that so-and-so group was using Bitcoin using Bitcoin transaction for doing XYZ activity. So that creates an image that since it is not trackable, I mean, it is just used in dark web and you can use them because it is completely anonymous. That is not true. Think about like a stage artist. Like every stage artist or almost every artist has a stage name and they have their actual name. But there is a mapping there. I mean, if moment the cover is blonde, if you know that this stage artist has this original name, then that person is no more anonymous. Same goes here also. Like every node on blockchain network have a public virtual address, but at the same time, that public virtual address is linked to an actual address. So there are ways you can actually track those transactions happening, though it is difficult, but not impossible. FBI was able to do it last year. So, and there are many such cases where people were able to track these transactions happening on blockchain network. Now, what blockchain is, as I said, it's a new way of documenting data on the internet. It's a distributed and digital database. It is pseudonymous, not anonymous. It is a foundation of Internet 3.0. So right now we are in Internet 2.0. It is era of HTTP and REST APIs and all. But future is Internet 3.0, Internet where everything will be decentralized. There will be no central authority, and blockchain is going to be the foundation of that Internet 3.0. Okay, let's talk about what consensus algorithms are. Now, I said that blockchain is a distributed and decentralized system, means there is no central authority and power is distributed across multiple nodes. But then if I have to decide in a blockchain network that whether the data which I'm going to add in this blockchain, is it authentic or not? Or if I have to add a new block to this blockchain, then who is going to decide that, okay, this block could be added and this is not eligible for that? All that processes, there has to be something. And because there is no central authority or there is no governing body to take care of all those things, that is where consensus algorithm comes into picture. Consensus algorithm, you can say that these are the foundation or core of blockchain technology, because in a decentralized system, you need a process, you need a decision-making process, which would be used to come to a conclusion. So I know power is distributed across multiple nodes, but there has to be some sort of protocols or guidelines which these nodes will follow in order to come to a common conclusion. So that is called consensus algorithm. Now there are various consensus algorithms: proof of work, proof of stake, capacity burn, proof of weight. But proof of work and proof of stake are two most popular ones. So let's talk about proof of work. Proof of work. Think of proof of work as a game. Like you have a treasure box which is locked by a combination lock. Now all the players in that game, they are trying to find a combination key. Whoever finds that combination key will be the winner, and as a reward, whatever is in that treasure box, that goes to that particular winner. Now this is what proof of work is, that all these players are basically, you call them miners. So all these miners, they are trying their best to solve a complex mathematical problem. And why are they doing that? Because they will get rewarded in return. Currently, that reward is, if you talk about Bitcoin blockchain, then because Bitcoin blockchain uses proof of work consensus algorithm, currently that reward is 6.25 BTC, and it gets half every 4 years. So initially, when Satoshi Nakamoto started this Bitcoin blockchain, it was 50 Bitcoin, but every 4 years it is reduced by half. So right now that reward is 6.25 BTC. Coming back to proof of work. So proof of work is basically a consensus algorithm where all the miners, they are trying to solve a complex mathematical problem. And what is that complex mathematical problem? So if you have to add a node to existing blockchain, they have to find this perfect nonce. So I told you nonce is the core of proof of work algorithm. So it's a 32-bit random number, and its abbreviation for nonce stands for not number used only once. So everybody, all the miners, they're trying hard to come up with this golden nonce, a number which which will fit with the existing blockchain. So thing is, like you take the data value, you append this nonce to the existing data value which you have to put in a block, and then you do hash it, like you apply a hashing function on top of it. In return, you are going to get a desired hash value. Now this this particular output hash value has to be lower than a target hash value. So this is how you are determining that who can and on what basis we are going to add a new node to this existing blockchain network. But again, this whole process, which is called mining, this is not easy. It is not economical at all, because that finding a nonce is a very complex mathematical problem, and it would require you cannot do it with the regular hardware, and you require a very complex hardware, which is costly, and also it is energy intensive. That is one of the reason why proof of work, though it is very popular, but now industries are talking about alternatives. So another alternative, I mean, one of the alternative for proof of work, which is popular, is proof of stake. Proof of stake is, we saw it in the previous slide. So proof of stake is, you can think of proof of stake as a lottery system. So it's like here, you don't have to solve any complex mathematical problem. It's just that you have to put something on stake. More you put something, that something is basically the base cryptocurrency of that particular blockchain. For example, if you're talking about Ethereum uses proof of stake. Earlier they were using proof of work, but last month they have switched to proof of stake. So if you're talking about Ethereum blockchain, they use proof of stake. So here, all the participants, they're called validators, they have to put something on stake. And more you put on stake, more are your chances of being selected. Similar to a lottery system, more lottery tickets you purchase, more are your chances of winning that lottery. So this is how, I mean, these are the different consensus algorithm, and most popular one, proof of work and proof of stake. And there are others as well, like proof of capacity, depending on how much storage you have, proof of burn, proof of weight, and so on. And around right now we have around 10,000, or I mean thousands of blockchain available in industries, and each one of them is using either this algorithm, or they're using hybrid of this, combination of few of this, or they can come up with their own consensus algorithm also. Totally depends on how they have implemented it. Okay, very important thing. What type of data you should store and where exactly you should use blockchain. So I mentioned in the first slide that you can use blockchain to store any type of data. But again, just because you can do it doesn't mean you should do it. Why? Because we already saw it in the previous slide. There is a cost associated with adding data on the blockchain. If you're using POW, then it is very energy intensive. You have to think about economics. You have to think about hardware costs. You have to think about energy costs. Second, if you're using proof of stake, then you have to put some cryptocurrency, the base cryptocurrency of that blockchain, as on a stake. So the thing is, like, there is a cost associated while you're trying to think of using blockchain as a database technology. So that decision has to be wise. Like, and where exactly you should use blockchain in your use cases, where these are the three main things which you have to consider. If you are looking for data integrity, you want tamper evidence, like you want that nobody should be able to change your data, or there should be a way. I mean, you want to enforce data security. Then you can consider blockchain. If you have to think about data decentralization, I mean, you don't want central authority. You want that power, or that trust building thing. In that case, like data transparency and all. In such cases, you have to think about using blockchain. So remember this, like, if you have to think about data integrity, data decentralization, and data transparency, these are the three things which you have in your application, or in your use case, then definitely blockchain is one of the options you can use. Okay, let's talk about a few of the blockchain applications. So first is money transfer. Again, very popular one. Everybody, or almost everybody, would have heard about Bitcoin, Ethereum, Ripple. All these are some of the blockchain applications which are used for money transfer. Now, with your flat currency, with Swift payments, if I have to do cross-border payments, it normally takes around 3 to 5 days. If I have to send someone money from India to United States, and it might take around 3 to 5 days with the existing flat currency model. But that same transaction can happen in seconds if I am using blockchain technology. So very promising use case, and I think it is already so much use. I mean, it is very popular. Bitcoin is now gaining traction. Not only Bitcoin, Ethereum and other cryptocurrencies are also gaining that attention. Second, supply chain management. So I have a detailed case study in the next slide, where we will talk about specifically about how beneficial it is to use blockchain in the supply chain management. Third is smart contract. So smart contract is, remember I told you that you can store any type of data in your blockchain. Not only data, you can even have some sort of code in your blockchain. So think of smart contract as self-executing contracts. So there is a piece, there are a bunch of if-when statements embedded in your code, and they get executed on a trigger of any event. So, and these are self-executing. You don't have to manually trigger them. So it's like, if this happens, then this should happen. So bunch of if-then statement you can code, and then you can put it in a blockchain application. Those are labeled as smart contracts. A very, I mean, one of the use case I can think of, insurance companies. So you buy a travel insurance, you are traveling with the airline, and your flight got delayed by say 3 hours. Now, the clause says that, okay, I have a valid travel insurance, so, and my flight got delayed by 3 hours, then I am eligible for a reimbursement. If that insurance company enables blockchain, like if they have a blockchain application for this whole process, then nobody has to do anything. I mean, you can just have a smart contract embedded in your application. So you can just code it in a way that, okay, if flight got delayed by more than 3 hours, then this should happen. Then money should be reimbursed to that consumer. Now, just imagine the level of customer satisfaction that this might give to that insurance company. I mean, as a consumer, I would be very happy if I get my money so quickly. And this is just one of the use cases I'm talking about. There are endless possibilities when it comes to smart contract. You integrate it with Internet of Things, and two bigger problem with Internet of Things, IoT, is that those solutions are not scalable, and there is scalability is always a problem with Internet of Things. But if you embed, and of course, data security is the other problem. Now, if you integrate smart contract with Internet of Things, and your two underlying problems are automatically solved. So smart contract has huge potential. Fourth is about healthcare. So yeah, blockchain could be used in healthcare industry too. There are few applications which are already there, and it has potential. I mean, you can automate you can create your EHR and EMR systems using blockchain. With this NFT, so we already talked about what fungible, what non-fungible assets are. Non-fungible assets are basically those assets which have a unique value. Now, NFT is a recent term. I think it's a buzzword which was trending since last year, when few of the artists, they basically launched their own NFT. Now, what is this NFT? It stands for non-fungible tokens. So, and this is a boon for creative side, like art and creative industry. Why? Because if I came up, if as an artist I come up with a art, and if using blockchain, using NFT, I can launch that art or that piece, that product with everyone. And as a consumer, one of my biggest challenge is that I don't know how authentic that art piece is. If I'm buying it from some XYZ place, I have to rely on the credibility of that place. Since I'm buying it from that place, I'm not buying it directly from that artist. So authenticity and that ownership is always a problem. That if you add blockchain to this problem, then if you launch that particular art as an NFT form, then you are solving that problem. Why? Because that way, as a consumer, I can directly purchase it from that artist. And since there's a blockchain technology enabled, I don't, that ownership thing goes away. I mean, I know that whatever I'm buying from that artist, I'm buying it directly. So there is no point of, I mean, there is no scope of forging or anything. Second, how is it beneficial for artists? Because as an artist, I can directly take that amount. That there is no middleman in between. There is no commission-based thing. Directly, those consumers can make a payment in cryptocurrency to my account. So that way, it is win-win for everyone. Next is about government sector. So yes, I mean, there are endless possibilities when it comes to government sector. I think one of the very popular one, which few of the state and central governments across the globe have already started, is using blockchain for e-voting. Now, every contender or every candidate, they can have a public virtual address, and then each voter or a citizen will have a unique ID. So if I have to vote, I can simply send that token to that particular candidate. That way, I'm ensuring that, okay, my vote is going to correct person. So with the traditional voting system using ballot systems and electronic voting machines, there are many problems associated, like booth capturing, or you can double voting and things like that. But if you are using blockchain with this e-voting thing, then there is complete transparency, and it also increases the trust in government. E-voting is just one of the use case of blockchain in government sector. Of course, there are other, like creating identity management solution using blockchain. So if I can have my identity, biometric, and SSN stored in a blockchain database. So since it's a blockchain based database, my information would be secure, and I know that the data integrity would automatically be there. If I have to share my personal information or SSN with anybody, then I can use this blockchain enabled application, and I will be more comfortable knowing that this is going to be a secure communication or exchange of information. So as I said, I mean, these are just few of the applications, and there are many more, which I think for supply chain management, as I said, I have this case study, which is very popular one. But before I talk about this case study, let's try to see what are the core challenges associated with food industry or like with supply chain management. So you buy something from any retail store. I mean, say that food which is coming on your dining table, you never know that there are so many entities which are involved here, like that food comes from a farmer's farm, then it goes to your processor, then it goes to distributor, then it goes to logistics, and finally to retailers. And also there are so many entities involved. And problem with food industry is that there are so many foodborne diseases, and food frauds are happening all the time, like dilution, substitution, illegal production. You might be buying an organic product, organic food item from a retail store, but you never know that whether it is organic or not. There is no way for you as a consumer to know that I am buying an authentic organic product. You are simply relying on the credibility of that labeling company or that retailer. So these are the few problems, and there had been incidents where these problems came. I mean, there had been incidents, like for instance, back in 2013 in Ireland, FSA, Food Safety Agency, they picked some random frozen beef burgers, and the idea was to check the quality of those burgers. And you know what? I mean, around 85% of those beef burgers had pork in it, and more than 2/3 of them had horse DNA in that. So it was very shocking. I mean, it was surprising at the same time, because you are relying on the credibility of that particular store, that okay, I am eating a beef burger, but you never know what type of raw ingredients they might be using. So this leads to multiple things, like lack of trust. You are buying something from a brand, and if you see that that is not what you were supposed to, I mean, that is what of course, like since you thought that you are buying the original thing, but you are getting a duplicate, or you are getting something else, then there is a lack of trust here. There are food-borne diseases as well. I mean, there had been incidents. So in that case, there is a possibility of life loss as well. And then we have lawsuits also, like in financial terms, many retailers and many food industry giants have faced this problem in the past. Now, these are all the problem statements. Now, how Walmart is solving these problems? So Walmart, again, it needs no introduction. Walmart is one of the very popular American retail company, which is selling around in 60 plus countries with 11,000 plus stores. So they did partnership with IBM, and they started two POC, proof of concept projects, back in 2016. Idea was that, okay, if I go in any USA Walmart store, if I pick a mango, I should be able to track it down from where it originated and what was the chain of events. Same goes for pork. Like if I go in a Chinese Walmart store, if I pick up pork, then I should be able to trace it down, like where exactly, in which slaughterhouse it was there, it originated, and then what was the chain of events. So they started this POC project back in 2016, and before this solution, it was taking them around 7 days to do that check. But with blockchain application, this POC project, they were able to narrow it down from 7 days to 2.2 seconds. That means if I take a serial number of the product, and within 2.2 seconds, I can determine that, okay, this particular pork was originated in so and so slaughterhouse on so and so date, and with the timestamps and everything, because blockchain keeps record of everything, like all the entities which were involved in between, you will have a complete trace, complete information with you. So how is this helping? Because for example, if there is an incident of origination of any foodborne disease in particular store, I do not need to worry about all the things. I can simply take the serial number of that particular product from where this whole thing originated. I can trace it back to that particular slaughterhouse, and then based on the batch number, I can determine that, okay, from this slaughterhouse, the raw material was supplied to so many retailers and so many processors, and that way you can do food recall. So you see like how you can do damage control in using this technology. Using this later, I mean, this POC project was materialized into something. I mean, it's called Food Trust. You can do some R&D about it, but IBM actually launched a product under name Food Trust, which is very successful right now, and companies like Nestle and all, they are already using it. Okay, to conclude, so yeah, blockchain is a new way of documenting data. It's a way you can store the data. I mean, underlying data structure here is chain of blocks, and how is it different than other technologies? Because you get data transparency, security, and integrity here, and it's the future technology. I mean, because cryptocurrency is just one of the use case, but think about smart contracts, NFT, and one of the use case which we just saw. I mean, there are endless possibilities. There are so many sectors like supply chain management, healthcare, government, etc., where this technology could be very beneficial. Yeah. So these are the few references which I've used in my presentation. Okay. Thanks for joining.
Thank you, Adi, for sharing with us all this valuable information. Now we are ready to start with our Q&A section. So the first question we have for you, Adi, is how blockchain is useful in healthcare domain?
Oh yeah, that's a good question, and I think I touched it a little bit in one of my slides, but I can elaborate more. So one of the thing is like you can have blockchain enabled EHR and EMR system. So you say you are a patient and you have to you walk in any laboratory, or say you walk in any pharmacy. Now you are paying for a vaccine or any medicine. Now you never know if that particular vaccine or that medicine is authentic or not. You are simply relying on the credibility of that pharmacy or the manufacturer or the labeler who did the labeling on that this particular vaccine is made by so and so ingredients, getting expired on so and so date. So all this information, you are simply relying on the credibility of that labeling company and the retailer or the pharmacy store who is selling that to you. But now think of this in a blockchain world. If you have a blockchain enabled application, you take a serial number of that particular vaccine, you enter it, and bam, you will get all the information, like where, in which laboratory it was manufactured, and on what date it was manufactured. And again, we are talking about blockchain. You cannot temper the data. You cannot change the timestamps and all. So that information which you can see, that whole chain of information would be very valid and very authentic. This is one use case. Another use case I can think about in healthcare, like if you have to share your health information or your if you have to share your PHI data or health information with anyone, you have multiple entities involved. Like you have your primary physician, you have your family doctor, then you have diagnostic laboratories, you have your caregiver. So that exchange of that health information between these different entities could be done in a very safe and secure manner using blockchain. So yeah, I mean, I hope I answered your question.
Thank you, Aditya. Does blockchain technology have a future?
Oh, absolutely. I mean, blockchain has future. It's a very promising technology. So right now we are living in Web 2.0. This is era where we're using HTTP and REST APIs and all. So here internet is controlled by, I wouldn't say controlled. I mean, here we have key players in the industry right now who are making major decisions, like Meta, and then we have Amazon and giants like this. But these are so this is internet 2.0. Now with blockchain, we are talking about Web 3.0, which is, and blockchain is the foundation of Web 3.0. This would be an internet without any central governing or without any central authority, where people would be able to do peer-to-peer transaction. They can exchange information without relying on any government, any third party and all. So absolutely, I mean, the blockchain is the future technology, and NFT, smart contracts and all. I think we already saw a few of these applications in our presentation. So yes, blockchain is very promising technology, and it has a very bright future.
Okay, thank you, Aditya. I have another question here. Is why don't we have many applications in production using blockchain?
Yeah, I mean, truth. I mean that's true. Though this technology is in since 2014, we are thinking about blockchain beyond. So we had a commencement of Ethereum in 2014, and after that, there are few applications which are in industry, which are in production right now, used in real time. The one which I already mentioned in my Walmart case study slide, IBM Food Trust. That particular product is very useful product, which is widely used in food industry. Giants like Walmart, Nestle, and all, they are already using blockchain-enabled application. But yes, to some extent, I agree that there are not many applications right now. Mainly, there are two things. I mean, main factor is that since we are talking with blockchain, we are talking about taking the control from the governing authorities. Like so, there is some resistance. There is some resistance from government and bureaucracy and all of that. So definitely there is a delay, but yeah, I mean, I can assure you that many projects are in R&D phase right now, and very soon we will see those live applications used in real world.
Thank you, Aditya. And the last question is, what are the limitations of blockchain?
Okay, I think probably if we do more of such informative blockchain, webinars and all, then we can overcome those limitations, because one of the major limitations we have is lack of knowledge, awareness, I would say. So, I mean, not many people in the web development background or in development background are they have that capability to work on blockchain applications. So that is one. So like to summarize, absence of that talent, that is one thing, one of the limitation. And second, as I talked about on the first slide, that blockchain we have decentralized and distributed system. So that means on every node we have a whole copy of blockchain. So there is some sort of data redundancy in place. And like if you take example of Bitcoin blockchain, so right now there are around 19 million Bitcoin mined, and the total chain is around close to 200 GB, if I'm not wrong, or maybe it is in TB. But yeah, I mean, so you can imagine like the cost which is associated here for performing this mining and all. This is on a very higher end, and this is one of the storage and scalability is definitely one of the biggest limitation I can think about, in addition to the lack of talent, of course. So yeah, these are the two which I can think of. Those are on top of my mind right now. Definitely there are more limitations, but yeah, these are the two things which I can think of.
Okay, Aditya, thank you so much for all your answers. And thank you everyone for joining us. Please keep an eye out for more webinars that we will be hosting soon. We also invite you to watch the recorded webinars we have posted on talks.coda.com. Thank you, everyone.
Thank you.
Bye.